Hey everybody, day 8 of our math time. Here's our math riddle for the day. No dice. K-N-O-W, mean no dice, not no dice. Come on, lucky shiny dice, roll a pair and count it twice. Boxcars, snake eyes, double threes. Can you add up all of these? Before you start, please look around. Adding's fast when tens are found. All right. Groups of two. 2 plus 2 is 4. 3 plus 3 is 6. 3 plus 3 is 6. 6 plus 6 is 12. 6 plus 6 is 12. 6 plus 6 is 12. So I got 12 and 12 is 24. And 12 more is 36. Plus 2 is 38. Plus 2 is 40. We finished our time book. And I found a little book about famous math people. And we're not going to read the whole thing. But I thought I would introduce you to some of their names. Thales of Miletus, who was born before Jesus, around 600 years before Jesus. He was one of the 7 wise men of antiquity and was the first known Greek philosopher and scientist. He is the first person with whom the use of deductive methods in mathematics is associated. 2,600 years ago. Of course, math was certainly used when they made the pyramids at the time of Moses. Thales. Interesting. All right. We talked about coin money yesterday and how that was used and why it's so good. So, did money make trade with other countries easier? Oh, definitely. Money was a great help. Everything had an agreed upon value with money as the common medium of exchange. There were a few new complications because not all towns and countries used the same money, but it made it much better than bartering. Once money was invented, did everyone use it? Well, no, because even though money made life easier, lots of people continued to barter, and people still barter today. At first, money was used only by wealthy people for important events like paying taxes. But for many day-to-day things, people still bartered, and workers often paid for their services with food, clothing, or a place to live. Other words to know. Counterfeit, currency, and denomination. Counterfeit is to make a copy of something that people will think it is real. That's stealing, and it's wrong. Currency, any kind of money that is used as a medium of exchange. The new one is called Bitcoin. Not always a good thing because it's only on the internet and you can't touch it. Denomination, the name of a group of things. And we use that with money because you can get a $1 bill or a $5 bill or a 10 or a 20 or a 50 or a 100. All right. Today we're going to count with M&Ms. Grandma bought a bag of M&Ms. So first we're going to open our bag of M&Ms and see what's inside. Ooh, so many M&Ms. So many pretty colors. I see yellow and green and brown and blue and red and orange. 1, 2, 3, 4, 5, 6 different colors. But I have lots of all of them. So hopefully I have enough to do what I need to do with the books. The M&M's Counting Book. This is not a Jerry Pilato. This is by Barbara McGrath. The M&M Counting Book. And there's the M friend, red and yellow. Pour out your candy skits. Ready, get set. This counting book is the tastiest yet. Oh, and look, we found them all a brown, a green, an orange, a red, a yellow, and a blue. I can put them in their order. Brown, green, orange, red, yellow, and blue. All right. This is certainly the most colorful mix. Now sort them as I do and count up to 6. 1 blue. There's, I got 1 blue. I wonder what color they're going to choose next. 2 green. 1, 2. 2 green. 2 green. 3 orange. 1, 2, 3. 3 orange. Colors next. 4 yellow. 1, 2, 3, 4 yellow. 5 red. 1, 2, 3, 4, 5 red. I've only got 1 color left. Do you suppose it's going to be 6 brown? Let's turn the page and find out. It is 6 brown ones. 1, 2, 3, 4, 5, 6. 6 browns. 1, 2, 3, 4, 5, 6 colors. 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. Keep the 6 brown. Push the others aside. Please use these pictures and words as your guides. So we got 6. 1, 2, 3, 4, 5, 6. I'll make my diagonal look like their diagonal. 6 browns. Okay. Now, to get to 7, add a blue to make 7. 6 plus 1 is 7. Now, put a green near the middle. And you have 8. Wonder how we're going to get to 9. Add a red to your group to make 9. It doesn't say where. I'll put it up here where I've got a little space. 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. We had 6 browns, plus 1 green, plus 1 red, plus blue. Oh, that's 3. 6 plus 3 is 9. Ooh, now add an orange. And we have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wow, that's really cool. 11. To get to 11, add a yellow one now. There's 11. Add a brown. And we have 12. Great work. Take a bow. You counted to 12. I knew you could. You want to move on? I thought you would. Ooh. Now put the 12 candies in a long line. We'll call this a set. You're doing just fine. Okay, this is our set of 12. One set. One group. A group of 12. Now, we're going to make 6 groups of 2, and that's easy for you. What does that make? 6 sets of 2. So, 1, 2, 3, 4, 5, 6. 6 groups of 2. 2 plus 2 plus 2 plus 2 plus 2 plus 2 equals 12. Or I can say 6 times 2 equals 12. Now, I had one long set, and I've broken it into 6 smaller sets. 6 sets of 2. All right. 3 sets. Change them around and make 3 sets of 4. Count them. How many? Still 12 and no more. All right. 1 group of 4. 2 groups of 4. 3 groups of 4. 3 sets. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Still 12, because 4 plus 4 is 8, plus 4 more is 12. Or I can say 4 times 3 is 12. 3 sets of 4. Oh. That's it. Okay. Now it's time to make 4 sets of 3. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 3 plus 3 plus 3 plus 3. 3 plus 3 is 6, plus 3 is 9, plus 3 is 12. Still 12. 3 times 4 is 12. 4 times 3 is 12. Doesn't matter how I mix them up, I still get 12. Two groups of 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 2 groups of 6, or 2 sets of 6. 6 plus 6 is 12. 6 times 2 is 12. Same idea. Ooh. My circles are making a square. Let's make 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 1, 2. If I put 4 on each side, Grandma's is kind of tilted up, so it's harder for her to make them stay in. You can probably make a prettier square than Grandma's. I still have 12. And I shape the candies into a square. A square is 4 sides. 1, 2, 3, 4, and 4 corners. 1, 2, 3, 4. We've talked about squares before. My circle's made a circle. I won't be able to make as good of a circle with my board tilted up like this, but I'll get it close. They want to slide. I bet you can make a better circle than Grandma does. My circle made a circle. So can we make a triangle with them? Do you remember what a triangle looks like? Tri is the root of 3. I have a tricycle that has 3 wheels. So a triangle has 3 sides. 1, 2, 3. Would be easier if it was on a flatter surface. Well, the surface is flat, but I have it tilted so you can see. Triangle, 3 sides. 1, 2, 3. Hey, this is kind of fun. Ooh, now comes the part that will be the most fun. We'll start with the scratch. Eat the blue one! That tasted pretty good. 12 minus 1 is 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's how many I got. Count and you'll find you now have 11. Next, eat the brown ones. All 7. 1, 2, 3, 4, 5, 6, 7. 11 minus 7 is 1, 2, 3, 4. Yep, that's how many I got. I like M&M subtraction. That works for me. Ooh. Now you have 4 left. So eat the green one. 4 minus 1 is 3. Now eat the orange one. 3 minus 1 is 1, 2. Now eat the yellow one. 2 minus 1 is 1. How many are left? Right. 1 minus 1 is 0 on our pile. I know we still have all these left. 0. Woohoo! 6 colors, 3 sides. Adding and subtracting. Lots of fun. Oh, wait. I have all these M&Ms left. You'd probably have some left, too. Do you think you could start over and do it again? Have a good day, guys.